Okay, excellent. So that concludes our session this morning on sustainability, 3 excellent talks. And what we're going to do is have a Q&A session now, a little panel discussion. Sorry, I concluded the talks, but not the questions. And so if anyone has questions, please do post in the chat. And I believe I can answer them. And Hamid and Gail, if you could ask to share your screens again, and we could get your faces up on here to help answer the questions. Here we go. Mm-hmm. We're very good on time. Thank you, presenters. That was very easy for me. We're well in time. We have 16 minutes left. Excellent. So let's go ahead and go through some questions. So if we look, Nora has a question, I believe. So
maybe I can take the panel.
Pardon me?
No, I just read the question, so please go ahead.
Yeah, well, I was looking at Nora if who it's actually directed to. So I think this is a question, and we'll keep it to the panel, and everyone can chip in. So Nora asks, are you considering another type of battery that can replace zinc magnesium oxide for a more sustainable material with a higher energy density? Who would like to tackle that question?
Yael, you want that one?
Yes, I can say a few words. Well, I will say the advantage of this kind of battery is you don't need a strong encapsulation. That is the main advantage. And zinc and manganese oxide are not very toxic materials. So for me, it's my best choice at the moment.
I maybe jump on the question.
I have no other battery in mind at the moment.
So if I may complete, and if I may complete my colleague. So, for example, at ICI, we have demonstrated the manufacturing, using a fully, roll-to-roll continuous process of those type of battery. And honestly, we took it because it was a very, very old chemistry, and so that was actually that was easy to formulate. I mean, easy to formulate. I think my colleague won't be laughing right now. So it was a nightmare to formulate those type of ink, actually, but we succeeded in doing so. So I must say we'll be very happy to do that demonstration with other type of material. But in our case, what we wanted to demonstrate was the manufacturing part of it. So no, we just have to formulate new inks. If someone wants to challenge us, I'm be happy to do that.
Okay, very good. Thank you. So Charles has a question here, and this is directed to Chloe. How easy would it be to integrate other printed technologies, such as inkjet, into the ICI process?
Actually, the press was made for that. So far it's a 5-unit press, and we have we have all the electrical connection and so on to have 2 extra units. And we were from the beginning in 2013 planning to integrate inkjet. So it will be hard, but it is actually still feasible. But what we do at ICI, actually, we want to represent the industry that we are serving. So, for example, if our customer wants us to go to high-scale inkjet, we will go to serve them. Okay, but it won't be pushed by the academic research, unfortunately. It's really to have technological transfer demonstrated at very large volume for the industry. And if I may complete as well on the battery part, some of the material are actually causing quite of chemical problems when you formulate them. So it's also what usually limits the choice of material. So we are very happy with zinc and manganese.
Okay, very good. Thank you. So Maria has a question. Again, this is to Chloe. I think it's more about the Green Network. Are you looking for international partners or just Canadian only?
So we have international partners. So maybe Greg, you can also complement on that. And we will be very happy to have more of those partners. So he has to be talked with Serge. I think he's also attending the conference. So Serge Beaupré and Mario Leclerc, I think, are here. Or you can talk with Greg as well.
Yes, yeah. If I could quickly answer that one, we're open to all partners. One of the mandates of the network is to really create awareness and exposure for green printed electronics. So we're very curious to see what the entire world is doing on this stage. Certainly, in terms of funding, there's restrictions where funding needs to remain in Canada, but we're very open to working with industrial partners worldwide. And we already have some partners and even academic institutions. It's really a worldwide effort and a worldwide issue. So we're very open to that. So Marie, please contact us. Another question from Yasser. This is to Gail. What challenges do you face in printed batteries?
Well, at the moment, the main issue is to have a quite high capacity battery. We need to print, let's say, quite a high thickness of materials for the two electrodes and for the electrolytes. And with a flexo machine, it's not so easy because with a flexo machine we print only a few microns or maybe 10 microns to be when we have the south wind. And yes, that is the main challenge, is to print really a high thickness materials and yes, I'm working on it.
Okay, thank you. Thickness is a challenge. We face that too, and we do a lot of printed organic photovoltaics, and sometimes we need 500 nanometers. The thickness is a real challenge. We understand.
But maybe we can collaborate with ICI in the future.
So if I can comment on that, sometime we used to do 7 passes on the press, printing 4 units. That can give you an example. So registration becomes a trick.
Okay.
Okay, so we have another question. This is from Jean David, and he says, this is actually a very, very neat question. I like this one. Are there bio-based plastics to use in flexible electronics that can be as good as wood paper in terms of biodegradability? Excellent question.
I think they are. Like we talk about the shellac. So I'm not really sure of the biodegradability parameters we are talking here, but I think they are. We also have the polylactic acid that we can actually work on. What I really like, because, okay, I did the same school like Gail. So at the base, I'm a printer and paper manufacturer. Okay, so I really love paper. So I think using a lot of cellulose is really interesting. We can have those super highly refined fibers, very pure, that give you like, you call that tracing paper. So imagine a super high quality tracing paper could be really amazing. So I think we can clearly use many different sources of bio sources, and also I'm not really fond of using polylactic acid because usually it came from the amidon, okay, the starch come from food stock or stuff like that. Is that the right word, food stock? So it also has to be taken carefully. So I don't know, Gail, if you have an idea, or Hamid, if you have, you can comment on that.
No, me, I'm fond of cellulose, so I'm print mainly on paper. Yeah, for some project, I print some plastics, but it's very rare when I don't know, transparency, when you need something to place on the windows, for instance. And here I cannot use paper yet, but yes, I'm working also on transparent paper. But
very good, thank you. But yeah, very important question. We use a lot of PET in our lab, and that's not very sustainable.
But there are some plastic that are actually quite recyclable. So as well, the choice of plastic, even if it's not from biosources, it's really also can also impact that. Hamid, I think Hamid will be maybe the good one to answer that. No? No,
yeah, Hamid,
you don't want the hot potato?
Plastic sorting, I have some experience. So I guess these days there are good technologies, radiation-based sensing technologies for identifying and sorting plastics. The challenge in plastic is especially with black plastics. If you want to actually use those radiation-based identification, black plastic posing challenges because they absorb most of probing energy. But having said that, there are quite a number of cool research is going on, to, for example, use of other types of technologies like terahertz sensing, which basically pass through the bulk of material and be able to even identify black plastics effectively. And so there are good technologies coming out, that which help us to sort plastics when they end up in recycling plants.
Okay, thank you very much. We have another question popped up in the chat. This is from Charles again, and I guess he's going to be asking Gail this about the printed batteries. Is the process repeatable for battery printing?
Repeatable? You mean? I can answer. I hope I will answer the. On our FlexoPress, we have a vision system with a very accurate camera for the radiation, and we analyze, in fact, in quality control every object let's say it's not an IA, but it's very close to, and so yes, I don't see any issue here. I mean, my main issue is thickness. It's very.
If I can complement that, so imagine printing industry was able to print millions and millions of copies, for example, of some journals and magazines and so on. So we are really relying on the exact same technology and improving the quality control and also the control of all our unit systems. So I must say this is quite. I will be happy to host and to have people come and to see those battery printed. And when we print battery, I think Gail is the same. We print hundreds and hundreds of meters of those batteries. So usually our small run are about 1 kilometer of batteries. To give you an idea, so we have a web at least 1 kilometer, and you have. I cannot say too many details, but you have a lot of battery by square meters. I just say that. So yes, it's reliable. What is also interesting is to have some complementary that actually test all the batteries, so you can actually remove those that might have some trouble. But I cannot talk about the yield as well, but it's pretty high, the good batteries that are produced using those techniques. So it's very reliable, but it costs a lot to industrialize due to the ink formulation challenges and encapsulation.
Okay, thank you. Great answer. So it's making progress. Okay, so I see no further questions in the chat. But as chair, I reserve the right to ask a couple questions, I think. And I specifically one for Hamid. I was very impressed with robotics and the recycling. Maybe I missed it. What was the throughput, for example, on the hard drives? Like, how many hard drives could you recycle in a week or a month?
The recycling of hard drive, we aiming like a 1 minute is a target tactile time for dismantling on a hard drive. Right now, I mean, obviously that's our target. Right now we achieved around like a 3 minutes takt time, and we're like improving it. We have ideas, how to like speed up the process. So that's the goal, that we eventually be able to dismantle the whole hard drive in 1 minute.
Okay, thank you. Now conceptually, how many hard drives are there in the world that you would need to dismantle? Would this be plant running for years and years, or
actually, Yeah, good question. It's like everything else, models, electronics models, are changing. We used to have like a hard drive, now that use basically platters and disk. Now it's switched to SSD, solid state hard drives, and so our goal here is to be able to encompass all sort of types and models in our robotic system by having like a flexible grippers that can nest all size and shape and type of devices, and it's there are lots of actually this storage, information storage systems that coming from data centers, right? It's and then they have there is like a replacing their outdated ones, to switch to the new ones, and I guess right now the data centers are really basically interested to find a way to recycle their old the units and replace them with the new ones. So there will be like a demand, moving forward, as far as we need like a storage system or storage devices to store information.
Okay.
That's what's needed.
Okay,
And
cool.
yeah, I have like a small things to make, regarding automation and robotics. If you have time, I'll just go over it, just to let you know.
Well, we'll have to do that. We have to get moving on right now for the next session. But that was a good answer. It's very fascinating. Very, very fascinating. So thank you, everyone. Let's thank our presenters. Let's thank the audience. Let's thank the questions. That was excellent today. So this concludes the session in sustainability. Bye for now.
Super.
Thank you very much.
Bye-bye.
Thank you all.
Bye-bye.
So no.